Good morning, grade 9. Today we're going to talk about dividing powers. So we saw last time how to multiply the powers. Now we're going to talk about dividing powers. So let's say if I have 9 exponent, let's say 5, divide by 9 exponent 3. So again, I'm going to do the same thing as I did with the multiplication. I'm going to say how grade 8 they will answer this question and how grade 9 they should answer this question after having the information about the exponent law. So for grade 8, they're going to break down the 9 to the power of 5. So 1, 2, 3, 4, and 5. And it's saying divide by. That means I have to use the fraction bar. 9 to the power of 3. That means 9 times 9 times 9. And after doing that, they're going to say this equal to, I can simplify the first one with the first one, second with the second, the third with the third. I'm going to stay only with 9 times 9, which means I can say 9 to the power of 2. This is grade 8 way. But grade 9, they should know now that we have the exponent law about the division. When we divide, let's say, base A to the power of m divided by A to the power of n, since I'm using the same base, that means the answer will be A as a base, but now since it's division, we're going to subtract the exponent. So in this case, I have 9 as a base to the power of 5 divide 9 as a base to the power of 3. Since it's division, that means my answer is going to be 9, but I subtract the exponent, which means 9 to the power of 2. And this is exactly the same answer as the student on grade 8, they got it, but can you see that means like grade 8, they have to work a little bit more and break down 9 to the power of 5 and 9 to the power of 3. And imagine if we have large number, it's going to take too much time to break it down and to simplify. But with the exponent law now, it's going to be a little bit easier. So let's practice some examples. It's saying simplify. I didn't say evaluate. It said simplify only each of the following. I have base 3 to the power of 7 divided by base 3 to the power of 2. I have the same base, therefore I'm going to use the same base. However, for the exponent, since it's division, I'm going to subtract the exponent. So it's going to be 3 to the power of 5. The next one, I have here the fraction bar. I have 2 to the power 13, 2 to the power 11, 2 to the power 7, multiplication and division. So I'm going to deal first with the multiplication. So 2 to the power of 13 plus 11, because I'm using a multiplication here. Divide by 2 to the power of 7. So 13 plus 11, that means I have to the power of 24. Divide by 2 to the power of 7. Here, since it's division, and since it's the same base, that means 2 to the power of 24 minus 7. And here, it's going to give me for sure 2, and 24 minus 7, that means I'm going to remove the 4, it's going to be 20, and I remove another 3, so it's going to be 17. Next, if I have something like that, I have to be careful that in this case, I have 2 different bases, base of 3 and base of 5. So I have to be careful from that, how to separate both of them. So in this case, I'm going to say what? I'm going to deal one by one. So the 3 first as a base of 3, I'm going to add 21 plus 2. That means it's going to be 23. Time, I'm going to deal now with base 5. It's 11 and 10. That means 5 to the power 11 plus 10 equal 21. Divide by, I'm going to leave the 3 to the power of 10 and the 5 to the power of 9. And now I'm going to deal with the division. I'm dividing, that means I subtract the power or the exponent. So it's going to be 23 minus 10 times 5, 21 minus 9. Now, 23 minus 10 is going to be 13. That means 3 to the power of 13 times 5, 21 minus 9. If 20 minus 9 equal 11, that means this one is going to be 12. This is how we can think about the subtraction. In this case, we will have only one question, which means we used it before for the multiplication. Now we're going to see it in case of division. If you remember, as I told you, if I have something like that with unknown exponent, I have to think with this way. I have a right side and I have, I have a left side has to equal to the right side because I'm dealing with an equation. So the right side is easy, 13 to the power of 20, but what about the left side? It's 13 to the power of 34 divided by 13 to the power of x. Since these two terms equal to 13 to the power of 20, and since I have the same base, that means I can take the exponent and can say 34 minus, because I'm dealing with division, x has to equal to 20. Now, as you know, from the inverse, if I want to separate the x, or I can transfer the x to the other side with a positive sign, so I can say x equal 34, and I bring the 20 to the left side with negative 20, so that means 14 equal x. And now I can verify, is really 34 minus 14 equal 20? For sure, yes, that means my work is correct. Next one, I have again an equation, and I know that because I have the equal sign. So that means the left side has to equal to the right side. So the right side is easy, but the left side I need to work with it. I need to find the x. Here I have 5, 5, 5, and I'm lucky to have the same base. That means for the multiplication, I'm going to say 11 plus x because I'm multiplying. And now dividing, I have to say minus. But the exponent here is negative 3, so I have to be careful. All of that equal to the 5 to the exponent or to the power of 20. Since I'm using the same base, I can say that the exponent here equal to the exponent in the other side. So now you know from the integer that negative times negative equal positives. That means 11 plus x plus 3 equal 20. Now, if I want to isolate x, I can do that. 11 plus 3 equal 14 plus x equal 20. I can use a inverse method, so I can say since 14 plus x and I want to isolate x, I'm going to say negative 14 equal to 20, again negative 14. Whatever I'm doing at the left side, I have to do it at the right side to keep the balance. So this 14 and negative 14, they cancel each other. That means x equal 6. Now, as a verification, is 11 plus 6 minus 3 equal to 20. I have 11 plus 6 plus 3. That means I'm going to check now. 6 and 3, it's 9. 9 and 1, 10. 10 and 10 equal 20. That means I did a great job. I hope you understood how we can divide the powers, and thank you for your attention.